Hello, everybody. Martin Lehner here, Orange Technology. First of all, if you watched the last video, you'll realize it's chopped off at the end. Uh, Half embarrassing, but I take these videos on my BlackBerry Priv smartphone. Again, 720p, 30 frames a second. Um, Creates a 30 minutes video, creates about a 3 gigabyte file. Again, if you've been following me, I live in an area where there's limited internet. Speeds aren't a problem, but usage is. So I only get about 100 gigs. I think it's 110 exactly of internet usage. So if their videos are 3 gigs each, literally if I uploaded a video a day, I would be out of bandwidth for anything else. So I upload videos Monday, Wednesday, Friday, and I've chosen to go with 720p, 30 frames a second, just because that creates a small enough file, but the quality is still good. So, I take these videos on my BlackBerry Priv smartphone. I use the front-facing video camera on it. That lets me look at the smartphone is actually in front of me, and the screen is showing towards me. That's why I'm using the front-facing video camera, and it lets me see a preview of what's going on, so I can see where my hands are and where I am, if I'm out of frame or whatever, right? And so I have a 32 gig micro SD card on there, and that's what these videos are saved onto. Unfortunately, that card got full. Literally, that card got full and it stopped recording. Wasn't a huge deal, simply because I was basically done the topic anyways. I was only going to say a few more things. So the video is still good enough to upload. I didn't have to retake it, but it does get chopped off at the end. So sorry about that. Well, I freed up room on the card. I don't think I'm going to have that issue again. But, well, that's what happens, right? So in this video, I want to talk about web caching. This is actually something that was very important about a decade ago. There was, if anybody who knows anything about web caching, you'll know something called Squid server. So that is it's actually a Linux based server for web caching. It's an open source system. It's probably the standard in web caching, outside of the very, very high level ISP series, the ISP grade equipment, which is above enterprise equipment. So this is what ISPs and telecommunications providers would use. Squid server is pretty much the standard. It's kind of gone by the wayside. There's not a lot out there anymore for web caching, and I mean, there's simple reasons for that. Internet connections are a lot faster. That's the primary reason. Usage allowances has just gone through the roof. In a lot of places, and in a lot of metropolitan places, there aren't really usage caps anymore to begin with. Even if there are usage caps, generally, if you hit them, you just wind up going at a slower rate for like the rest of the month. So it's kind of like a fair access policy sort of thing, where you get, it's called being fapped. So they reduce your speed once you hit a certain threshold, but essentially you can still use the internet no problem. So caching is not really that important. I would actually argue that caching is still important. I mean, for those of you who are in Silicon Valley, yeah, you don't need to web cache. Everything's fine in Silicon Valley. You have access to multiple ISPs, internet service providers. Caps aren't really a thing you have to worry about. You in these types of areas like Silicon Valley, you can get fiber optic service fairly easily, et cetera, right? And the thing is, what I find a lot of technology professionals think about is they think in that narrow scope, right? This is how it is in Silicon Valley, so this is how it's going to be, here, X, Y, or Z, wherever you are, right? This is how it's going to be here. And they look at that at a very narrow lens, right? The world is looked at with a very narrow lens. What works in Silicon Valley works everywhere. That's really what I've seen with a lot of technology professionals. And the bottom line is that's just not true. I mean, it's just not true. The solutions that work in Silicon Valley because, again, Internet's good there, latency's low, there's a lot of services there, it's kind of a hub. You just don't need to web cache. But that doesn't mean you don't need to do it elsewhere, right? Bottom line is the majority of the world does not live in Silicon Valley. The majority of the world does not have 8 millisecond latency to Google and things like that. For example, our average latency up here to Google is 80 milliseconds, right? That's actually quite high. And the reason is because physically, geographically where I am, so for those who know me, I live in Whitehorse in the Yukon Territory. That's on the Canadian side of Alaska. I am 2 hours away from Alaska, from the border. And just the distance we have to travel to get south to hubs like Seattle, like, Silicon Valley, LA, those kind of areas, it just takes a long time, right? I mean, transmission over fiber optic is at the speed of light. Same thing for radio, for microwave if you're going wirelessly. But I mean, transmission is at the speed of light. That's a limitation. You cannot go faster. So physically, you can't go faster. This isn't a problem of the ISP not providing fast enough connectivity or anything like that. I can have criticisms about our ISP. We do only have one ISP. Bandwidth caps are one of them. But, one thing they're limited by is geographically where we are. And physically, they cannot move traffic faster than the speed of light. That's just physics, right? And, based on that, the experience that I have on the internet is not the same experience that someone else will have on the internet. Somebody in Silicon Valley will have a vastly different experience than I will. That's just a fact. Quite frankly, the majority of internet users in the world will have a vastly different experience than those in Silicon Valley and Seattle and New York and areas like this, right? I mean, if you think about it, almost 1 billion people live in India, right? I mean, India is geographically halfway around the world from the United States. So their latency times are just going to be higher. That's just a fact, right? Their latency times back to the United States will be higher. I don't know, does Google have data centers in India? I would assume they do, just based on the population. They have data centers worldwide, so obviously the latency to Google's data center in India is not going to be that much. But anyways, my point is, if you look with a narrow lens at what Silicon Valley's like, and you just try to mimic that anywhere else in the world, it's not necessarily going to work out, right? So this is where we get into the topic of web caching. So first off, what is web caching? So web caching, basically you have an appliance. I don't have one now. I have a couple clients that have these appliances. It kind of looks like this. This happens to be actually a phone system, but this is a Curio phone system, IP phone system. But basically, it's an appliance that looks like that. It's a 1U rack appliance, and essentially what it does is it goes in between. Well, there's a few ways to configure it. The simplest way to configure it is it basically goes in between your edge router. So that's the gateway router right before your internet modem or whatever you have, and so it goes in between your internet modem and your router. So what happens is, let's say you have a number of computers on your network, okay? Let's just say it's a handful, whatever number you want. So you deploy this web caching server and you've got it all running. Okay, so computer one asks for, I want to go to, I don't know, pick a website, CNN.com, okay, CNN.com. So it goes and it asks, I want CNN.com. The router goes, okay, we'll send that out to the internet. The web caching server intercepts that request and says, okay, this person wants CNN.com. Do I have that cached? No, I don't. Okay, so it goes out to the web. It asks for CNN.com. CNN.com responds and transfers all of its data in. What the web caching server does is it saves a copy of that website and all the content on it while it's being delivered to computer one, right? So computer one's getting this straight off the internet, And as it's coming back, as the images and the text and everything are loaded, the web caching server is saving a copy of that website. Okay. Now let's say 5 minutes later, computer 2 asks for CNN.com. So the request goes out. The router says, oh, okay, CNN.com. That goes out to the web. It sends it out. The web caching server, remember, it's between the router and the modem. The web caching server sees that request, says, hey, I have a copy of CNN.com. We don't have to go to the internet. And it delivers that copy back to computer number 2. So the request actually doesn't have to go to the internet. Now, what are the advantages of this? The primary advantage is obviously bandwidth savings, right? You're caching this website. So if this website is asked for 100 times, you've only downloaded from the internet once. Again, depending where you are, maybe this is completely irrelevant, right? You have unlimited usage. You've got a 50 megabit per second connection. It's not a big deal, right? I would argue primarily you look at web caching because it saves bandwidth, right? That's the primary driver. But there's other drivers too that you need to be thinking about. Even if you say, well, I've got unlimited internet, I don't care. I'll go to the web or the internet 100 times to get that web page. It doesn't matter. You also have to think about the experience for your users, right? So for example, let's take a hotel, for example, okay? You have a hotel and you have, let's say 300, or let's say you have 150 guest rooms and the average guest has 2 devices. Because this is true. In this day and age, every guest has 2 devices. It used to be in the past, every other guest or something would have a laptop. The people who are a little bit more fluent had a laptop, mostly business people, right? The average person didn't really have a laptop. Well, maybe they did. Okay, right? One laptop for, the family, a pair, traveling, whatever, right? So they had 1 device. Nowadays, the average person has 2 devices. This is generally a laptop and a smartphone, or it is a tablet and a smartphone. But think about this, right? A lot of people have smartphones. And what's the most expensive thing about a smartphone? Your data plan. So everywhere you go, if there's Wi-Fi, you connect up to Wi-Fi, right? Why wouldn't you, right? Then you don't pay anything for your data, or you're not consuming the data that's in your rate plan, in your cellular rate plan. So if the average guest has 2 devices, which is true, I'm seeing this real time, right? So this is true. If every guest has an average of 2 devices, if you got 150 rooms, that's 300 devices on your network, right? If everybody on the network is trying to stream the latest YouTube viral video, let's take Chewbacca Mom, for example, now you've got 300 people all trying to stream the same thing at the same time. Or if, let's say there's a weather warning, right? Let's say there's a hurricane, a tornado warning, whatever, and everybody's going to the National Weather Service to see what's going on. Do I have to get out of here? Do I have to take refuge? Whatever. Again, 300 devices are all going to the same thing. What happens is generally, you oversell bandwidth, right? There is a average model for overselling bandwidth. In the ISP market, an accepted model is 20 times for residential service. So if you sell a 5 meg internet service, right? 5 megabits per second internet service, you can sell that. Well, sorry, let's scroll back a little bit. Let's say your pipe that you have as an internet service provider is 100 megabits per second. You have 100 megabits per second backbone to the internet, okay? You can oversell that 20 times. Because of how internet traffic is used, and generally speaking, especially in the residential environment, people don't consume their entire speed that you sell them 24 hours a day, 7 days a week, just because of how those requests for information and get sent and received and that kind of thing, you can generally, the accepted average is overselling by 20 times. So if you have a 100 megabit per second pipe, you can sell that times 20, right? So if you're offering, 5 megabits per second, that would be 20 clients if they were all going the full speed. But again, you're overselling it by 20, so you can put on 400 clients on a 100 meg pipe, selling them 5 megabits per second max speed, right? Now, the problem with this is, using those models, again, I mean, if you got 300 users in a hotel and you're letting them all use the bandwidth, generally speaking, I mean, a hotel of that size is what, 30 megabits per second to service, 40, 50 maybe. You're going to clog the pipe, right? Especially if there's something going on where a lot of people are accessing the same information. So how does web caching help? Well, the thing with web caching is it takes the onus of basically the pipe off of the internet, off of your WAN connection, and puts it locally. So now instead of delivering, let's just use Chewbacca Mom, the YouTube video as an example, instead of delivering that video all off the internet, everybody streaming it at megabit per second or whatever they can get out of the pipe, if one person grabs it and it is saved by the web caching server, then it can now be delivered, and the limitation now is not your 30 megabit per second pipe or 50 megabit per second or whatever it is. It's literally the limitation of the appliance and your local area network, your LAN. Again, the web cache server that I have deployed for most clients, I have the same one deployed for anybody that has one. It's a gigabit per second Ethernet card in it. They have high speed hard drives in them. So really, I mean, I can deliver a gigabit per second on this local traffic, right? On this local content, this cached content. Now, if 300 people want to look at the same video, I can push it to the wireless deliver or the Wi-Fi system. I can deliver that at a gigabit a second versus, let's just say, for example, 30 megabits per second on WAN, right? I've increased the capacity a lot. Not only that, but there are going to be people wanting other things other than that video. So say 80% of the users are looking at that video, the viral video, but the other 20% want to look at something different. The pipe, the WAN pipe, the internet pipe is now cleared of that 80% traffic. And now those people have a better experience getting out to the web because they're not looking at the same thing that everybody else is that's already cached, right? So this is one of these things where a web caching server, yes, does save you on bandwidth usage, but it also increases the quality of service for the rest of the users, for the network on a whole. Because again, if half of your users or whatever, 80% are looking at the same video and they can get that cached locally, they will get that way faster than they will off the internet. It'll load super fast and they'll go, wow, that was fast. The other 20% are going to be able to do whatever they want to do on the internet faster as well because they're not having to compete for space on the internet pipe, on the WAN pipe, with the people trying to stream that video, right? And this is one of those things you really have to think of. Even though a technology, web caching in this case, even though a technology was built for a particular reason at a point in time, again, I mean, they were really popular about a decade ago. And again, it was because of internet speeds, internet usage caps, that kind of thing. I mean, 50 megabits per second wasn't standard back then, a megabit per second or 2 was standard. So this sped things up. It was necessary, right? These days, the primary purpose of these web caching servers, especially smaller scaled ones for businesses and such, maybe the primary purpose isn't that needed anymore, but the secondary purpose for network management and for availability and experience, it still has an impact on that, right? So just because again, you think of web caching, you're like, oh, we don't need that. We have a faster internet connection. We don't have usage. It doesn't mean it doesn't have a purpose still. And this is what I'm finding. This is what I'm finding with a lot of technologies out there, and a lot of people who really have this hyper focused lens. Right? Let's see what Silicon Valley's doing. Silicon Valley doesn't care about web caching. Why should we? But again, everything is based on where you are, geography, situation, all of this stuff, right? Just because maybe we don't need it in Silicon Valley doesn't mean it's not useful somewhere else. And again, not only that, but maybe the primary purpose isn't really that useful to you either, but a secondary purpose is, or something else that happens because you implement this, right? Secondary effect, that kind of thing may make complete sense. Again, I mean, web caching servers. I have web caching servers in a number of places. I do have them in hotels. I have them in medium-sized enterprises. I have them in some governmental agencies, right? And again, part of the reason for having it in these areas is because it makes sense. It makes sense because of bandwidth usage. It makes sense because of speed. It makes sense because the amount of traffic that's saved, I can choose to purchase a smaller WAN pipe costing less money every month, both in terms of usage and speed, because all of that traffic isn't hitting the internet anymore, right? And again, I mean, internet is not cheap, right? Where I live, internet is not cheap. For a 16 meg down, 1 meg up, cable internet connection at home, again with 110 gigabytes a month of usage allowance, I am paying, it's just shy of $100, right? That's how much it costs. If I go over the 110 gigabytes, I pay per gig. I believe it's $2.50 a gig. Don't quote me on that. It might actually be a little bit less. It might have gone down to $2 or so. But it's around that. It used to be a lot higher. It used to be like $7.50 a gig a while ago. That was expensive, right? I mean, you think you go 10 gigs over, it's under $75, right? So it has come down substantially. But the bottom line is there's a cost to that, right? Business internet, a 50 megabit per second connection down, and I want to say 4 megabits up. It could be 5 megabits up, something around that, and 400 gigabytes of usage per month. That is $400 a month, right? And there's packages below that, of course. So there can be like hundreds of dollars a month savings by being able to take some of that WAN traffic out of the WAN, out of the internet, right? So again, this is just one example, but there are a lot of things out there that make sense, right? I'm just thinking in firewalls, in modern UTM, Universal Threat Management, appliances. Those are our routers, firewalls, intrusion prevention systems, gateway antivirus. They're all bundled into the same appliance. That's the new way to do firewalls, basic firewalls. One of the options in a lot of them now is application control, where you can stop peer-to-peer, right? You can literally stop the ability to access peer-to-peer. Okay, well, again, why would you want to do that? If internet bandwidth is not a big deal and you don't have overage fees and there's no real usage caps, why do you care if somebody uses some torrenting or whatever, right? But again, that's consistent traffic, right? How does that affect the rest of the users on the network? There are other reasons to deal with that other than simply cost of internet and cost of bandwidth, right? There's other reasons. And these are the things you really need to think about. Again, if all you're thinking about is what do they do in Silicon Valley? What do they do in Silicon Valley? You're never going to think about that. You're not going to care about that. But again, maybe you should. Maybe you should be thinking of it because you're not in Silicon Valley. You are somewhere else. Again, the majority of the world does not live in Silicon Valley. The majority of the world does not live in the United States, right? So there's so many things to think about and so many things to evaluate that you can have that hyper-focused lens that so many IT professionals, so many technology professionals have. And it's just, it can get extremely frustrating, right? Because as soon as you start to talk about this stuff, and as soon as you start to expose some of these people to these things, they start to think and they start to go, okay, I never thought of it like that. But again, it's our job as technology professionals to think about these things, to think about the physical location, the geographical location, the situation, the particular challenges that one client or a company or whatever has, and to deal with those, right? We're not paid to just see what Silicon Valley's doing and go from there, right? So yeah, that is coming up on the, I think, 26-minute mark, and that pretty much rounds up this video. So that is my little spiel on web caching and why I think web caching is still relevant, is still important for different reasons, for not necessarily the same reasons, but for different and subsequent reasons than perhaps they were a decade ago. So still something to think about. I know somebody did ask me before which web caching server I do use. I use something called a cache box from Appliances. Again, Appliances. Cashbox, if you want to have a look. That is my experience is that is an excellent product. I've always purchased their product. I've never gotten anything free from them, just so you know. But I've used theirs, and it's very easy to use. It has the ability to just drop into a network. No additional configuration required. No proxies if you don't want. You literally can just drop it in transparent mode. Works really well. And yeah, I absolutely would say take a look at web caching, learn about web caching. It is something that, again, in my opinion, I believe is still very much relevant. And yeah, so that is it for this video. I will see you guys at the next one.